Hello everyone, welcome to Online Math Hub. In our today's class, we have this question for us to solve, and basically we are going to be evaluating this function, and that is we're going to be integrating sine cube x. I'm going to show you how you can actually integrate this kind of functions whenever you come across it in your question or in your exams, and it is just pretty much simple. All you're just going to do is make sure you watch this video to the end, and of course ensure you understand every step we are going to be taking to integrate this. And of course, if you are just new to our channel, do what to hit the like button, subscribe to our channel, and also turn on the notification icon so that whenever we release new content, you will actually get to know more about it. And of course, you go ahead and check it out. So we're gonna proceed right away to solve this question. Okay, so I'm just gonna go ahead to repeat the question: integral sine cube x dx. Okay, so what I'm gonna do is I'm gonna rewrite this, and of course, you know that this is also equal to sine squared x dot sine x dx. Okay, so I've split this sine cube to be sine squared x times sine x. So if you multiply it, you still have your sine cube. Okay, now what do we do again? We're gonna use a trigonometric identity which we know, which basically says that sine squared x plus cos squared x is equal to 1. So if you want to make this sine squared x a subject of formula here, we're going to be having that it is equal to 1 minus cos squared x. So we are going to carry this to replace our sine squared x right here. So, and if we do that, our new question becomes sine. So I'm going to replace this 1 minus cos squared x into bracket this sine x dx. Okay, so what do we do next? What I'm going to do again is I'm going to use this sine x to actually multiply the stuffs inside the bracket. And if I do that, what I'm going to be having is integral sine times 1 sine x times 1 will give us sine x minus this time this will give us cos squared x sine x dx. So this is what we are going to be having right here. Okay, so what do we do again? Of course, you know that the integral of a sum is also the sum of the integral. So I'm going to pass integral into these functions right here. And of course, if we do that, what we are going to be having is integral sine x minus integral cos squared x sine x dx. Okay, so this is also sine x dx. Okay, minus this. So this is what we have. And then what do we do again? We're just going to be integrating all of them independently. And of course, this has a direct integral. What we just need to do again is just to go ahead to evaluate this function right here. And we're going to be integrating this using substitution method. Integrating this function cos squared x sine x dx. So what we do is let u be equal to cos x, and of course if u is equal to cos x, this implies that our du is actually going to be du dx. Differentiating this u with respect to x will actually give us minus sine x. Okay, which implies that our dx is going to be equal to du divided by minus sine x. So what we're going to do is we're going to substitute all of these things right there. So we now have that our integral cos squared x sine x dx is going to give us, okay, so this is integral. We said that our cos x is u, so this is u squared, okay, and then sine x times our dx is this, so we're going to write du divided by minus sine x. Okay, so of course we can divide, we can use sine x to divide sine x. So what we are now having is that this is actually equal to minus integral u squared. Okay, so this is what we have, and what I'm going to do is just to go ahead and combine it with this one so that we can now integrate straight. So this, let me write integral sine x dx minus integral cos squared x sine x dx is now going to give us equal to Okay, so we have this integral sine x dx, which is this, and then minus, okay, this minus will multiply this minus, we now have plus integral of u squared. Of course, this is du, don't forget that. So du, okay, so this is what we have right here, and then you can see that we can now integrate directly, and we have that integral of sine x is actually going to give us minus cos x, okay, plus integral of u squared will give you u cubed divided by 3, and then plus our constant of integration. Okay, and then substituting for u, we said our u was cos x, so we're gonna substitute that. This is cos cube x divided by 3 plus c, and this is gonna be your final answer. Of course, if you like, you can also factorize cos, which since it is common there, so you can now have cos x into, let's write this one first, cos squared x divided by 3 minus 1. So this can also be your final answer. And I guess you have actually followed the solvings from the beginning to the end. You can see it is just pretty much simple. You just need to be able to remember the trigonometric identities, and of course, once you're able to remember it, you can always substitute it and then carry out your integration. So I'm going to be leaving it here. If you have understood it, let me have your thoughts in the comment section. And of course, if it is also confusing, if you don't understand any aspect, ask your question in the comment section, and I'll be there to help you out. And of course, as I leave, make sure you give the video a thumb up, subscribe to our channel, and also turn on the notification icon so that you will get notified each time we release more content. And then, of course, I'm going to see you guys in my next video. Bye.